Okay, welcome to our last lesson for this unit. This is called the mapping rule. We're going to do one page of a note together in the video, and you're going to have one page of practice, and then we're finally done this unit. So once you're done the practice and the lesson, you can now do that assignment on green paper. And then also this material will be on the test that you do when you come back to school in around a week and a half after Thanksgiving. What we're going to do in this lesson is finally learn how to graph parabolas. So far we've been sketching parabolas, where we put in the key information and kind of guess where the curve goes, or we've been using the computer program Desmos. But we can graph each parabola to make sure that every point is in its accurate spot. And the way we're going to do that is we're going to take, again, this basic or parent parabola. We call it a parent parabola because every other parabola is its child. And we're going to transform all the points in that basic parabola into the new parabola. So we're going to stretch and compress and move to the right and left until we have our new parabola. So we're going to start by making a table of values for this basic parabola. And we do any kind of table of values. Our starting point is we're just going to pick convenient values for x that we want to graph. So why don't we pick points around 0, so -2, -1, 0, 1, and 2. Remember that we know the vertex of this basic parabola, there's no h or k. The vertex is just 0, 0. We also know that because the way a table of values works is I'm plugging in 0 for x and then squaring it. So we know that 0 squared is 0. I'm just going to get a piece of paper so I can do a few more examples of how I'm going to make this table of values. So 0 squared is 0. If I want to find out, well, what's y when x is -1, I'm just doing -1 squared, which is just 1. Same thing, 1 squared is 1. If it's 2, well, I can plug in 2 into my basic parabola. And 2 squared is 4. And -2 squared is also 4. So that's going to be our starting point table of values that we use today, which are kind of the 5 points around the vertex of that basic parabola. And what we're going to do is we're going to transform each of these points into a point in our new parabola using what's called the mapping rule. And the mapping rule is going to use a, h, and k, those transformations, to create new points. So, for example, what does h do? Well, h moves the parabola right or left. Another way to say that is it's moving the x-coordinate of every point to the right or left. So when h is positive, we move to the right. So we're going to add h. So for example, if h was 2, I'd go 2 to the right. So I'm going to add 2 to every single x coordinate. We're going to practice this a few times. The next is k always moves us up or down. So in other words, we're adding k to the y coordinate. So if it's +3, the whole parabola moves up 3. I'm going to add 3 to every y coordinate. The last thing is what to do with a. A stretches or compresses the parabola vertically. In other words, we're multiplying every y coordinate by a. And we'll see how this works as we start graphing. So the mapping rule means I'm taking the original point on the basic parabola xy, and I'm transforming it into this new point, x plus h, and ay plus k. So let's take an example. We want to graph this equation, which has been transformed in a bunch of different ways from our original parabola, our original parent parabola. So my mapping rule takes every point xy, and I'm going to transform it. And I need to do x plus h. So h here is really -1. Remember, it's always flipped. So I'm going to take away 1 from every x, which is the same as moving every x to the left. Then I'm going to do ay plus k. Well, a is -3. It's going to be -3y plus k, which is 6. So it may help you if you want to write out each time, well, what's a, what's h, remember to flip it, and what's k. So that might help us make the mapping rule. And now we're going to put our table of values in. And I'm going to look at each coordinate separately. So for every x value, I'm going to take away 1, which is another way of saying I'm going to move it to the left. So -2 minus 1 is -3. -1 minus 1 is -2. So I'm following what this rule is telling me to do. I'm shifting it all to the left. For the y values, I'm going to multiply each value by -3, and I'm going to add 6. So 4 times -3 is -12. I'm going to add 6, so I'm at -6. Again, if you want to do this on scrap paper or in a calculator, So what I did on that first one is I took 4 times -3 plus 6, which is -12 plus 6. So my new y coordinate is -6. Again, I'm taking the old y coordinate, multiplying by -3. So it's going to be -3 plus 6 is +3. 0 times -3 is 0, plus 6 is 6. 1 times -3 is -3, plus 6 is 3. 4 times -3 is -12, plus 6 is -6. You might notice a pattern. If I transform these two y coordinates, well, it's symmetric, so these two will be transformed the same way. And now I've got points. Remember that each entry in a table of values is just a point. So for example, I'll just do this in red. You don't need to do this on your note if this already makes sense to you. But each of these is just a point. So I'm going to graph each of those points now precisely on my graph. So I've got -3, 1, 2, 3, 4, and -6. I've got -2 and 3. I've got -1 and 6. I've got 0 and 3. And I've got 1 and -6. So before you connect, you should, first of all, this should be doing a pencil if it wasn't a note. And the second thing we want to make sure of is it symmetric on both sides? Does it have a vertex and a change of direction? And then you're going to connect carefully. And this is not a sketch, this is a graph, because these actual 5 points are exactly where they would be on the parabola. And we can always check, is this reasonable? Well, this is what we expected to happen. The parabola has been reflected, it's opening down. It has a big a value, bigger than 1, so it's been stretched by a factor of 3. I've moved it 1 to the left, and I've moved it up 6 from the original vertex of 0, 0. So I've used this mapping rule now to graph this new parabola. We'll do one more example together. Again, you're more than welcome to pause the video, try it on your own, or you're more than welcome to do it with me, and then you'll have lots of time to practice on your own. Again, the mapping rule is always x plus h, ay plus k. I'm starting from my original points x, y, and this time I'm moving 3 to the right. Why don't we write down our a value is 1/2, our h value is 3, and our k value is -2. So I'm going to have x plus 3. It's going 3 to the right, so my x coordinate is getting 3 bigger. I'm compressing, so I'm multiplying all the y's by 1/2 or dividing them by 2. And then I'm shifting everything down 2 units or taking away 2 from every y coordinate. What's nice is that I'm always starting with this same basic parabola, so I can always use these same starting points. I'm always starting from y equals x squared. So if you even have these memorized or can generate these quickly, we can always kind of have that basic table of values. And now I'm going to use my mapping rule. First, I'm going to add 3 to every x value. -2 plus 3 is 1. -1 plus 3 is 2. So I just keep adding 3 onto all my x's. Because I'm shifting this parabola, it's been transformed horizontally to the right. Y values are going to be multiplied by 1/2. That gets me my compression, and then I'm going to take away 2. So 4 multiplied by 1/2, so half of 4 is 2, take away 2 is 0. 1 multiplied by 1/2, half of 1 is just 0.5, take away 2 is -1.5. Decimals are fine here because we're graphing, so decimals can be more useful than fractions. Next I have 0, half of 0 is still 0, take away 2. Half of 1 is 1/2, take away 2. Half of 4 is 2, take away 2 is 0. Again, once you've done those first 3 points, it's symmetric. So now I can graph these points. Again, every row in a table of values is an x, y coordinate pair that I can graph. So I'm starting with 1, 0. Then I have 2 minus 1.5. Then I have 3 -2, so 3 over 2 down. 4 minus 1.5 and 5, 0. So again, before I connect, you just check, yeah, this looks like a parabola, right? It changes direction, it has a vertex. It's symmetric on both sides. If it's not symmetric, then something's gone wrong. And, you know, it's not going to be a perfect graph all the way through, but for these 5 points around the vertex, it is a perfect graph because I've graphed each point accurately. And if we wanted to make more points, I could just extend my table of values to 3 to 4 to 5 if we wanted to. Last thing, just let's check that we've done this correctly. So I've compressed it. So yeah, it's around twice as fat or half as skinny as our normal parabola. It's shifted 3 horizontally to the right, horizontal translation right 3, and then down 2. So you're kind of always comparing it in your head to that basic parabola of y equals x squared. So that's the mapping rule. You're going to have to do a lot of these problems kind of on a separate piece of graph paper, maybe just 1 problem per page or 2 problems per page. You'll need lots of space. So your homework for the first one, problem 1, all I want you to do is write the mapping rule. You don't need to graph it. For the second one, I want you to use the mapping rule to make your table of values and then graph the parabola on graph paper. And then just a couple of challenge questions.